Hello, dear professor. It's me again, Wahid. In this video, I'm going to explain the fourth part of our data mining assignments, which is data interpretation. As always, I'm using Jupyter Notebook. I should import the necessary libraries to this environment, and after that I am calling my dataset and I am reading from the CSV files that I have already stored in my distro. This is my data for a stock market, and here this is the head of the data, and the first part of our interpretation is to understand what our data looks like. Okay, to do so, I'm explaining what is living in our dataset. Here in our stock data, it has about 1 million records, and I have 3 categorical attributes: sector, subsector, and company name. I'm just trying to get some understanding here. Our sector has 5 unique values, and the most accuracy of the values in sector is main market. Subsector has 20 different and distinct values with about 260,000 rows, and company names, which I have more than 1700 companies in this dataset. Okay, as I said, we have 5 distinct major market in this stock data: main market, AC market, bond, warrants, ETF, and 4 subsector: healthcare, energy, technology. First thing first, do we have any missing value in this data? I'm trying to check this question here, which is, fortunately, we don't have any missing value here. Is it null? Any? No, I don't have any. And this is the exploratory data analysis of the dataset: main market, AC market, accordingly, and from top to low it is ordered here, and for subsector as well. And the thing that we should consider here, the possibility as existing outliers in our dataset. That's what I have done here. I'm trying to demonstrate if we have any outlier in our stock data. And this is, I have plotted the box plot of this data, and this is the box plot, which seems weird. There is no actual real data here, and it makes me suspicious of existing outlier in our dataset. So I decided to create a function, outlier detector, and here I'm setting a threshold, which is 3, and I explain why. Let me show this one. If this is a normal distribution, and according to this picture, for data greater than Z, which is the normalized value greater than 3, all of those data would be outliers. Okay, and less than z equal 3, it would be not outlier data. So that's the ideology that I have implemented this data. I am using NumPy and stats from the actually SciPy library to calculate z score of our data for last price in stock data. And I'm saying as I explained in our picture, more than 3 would be outlier, less than 3 would be not outlier data. Okay, so this is our function, and I'm feeding the stock data to this function and create a tuple outlier df and not outlier df, and this is the head of the outlier df. So to understand whether we have done something useful, I'm trying again to plot outlier and also not outlier data again. Okay, this is my next box plot, which seems nicer here and more sensible. And if we just compare this plot with this one, yeah, it does make sense here. So, and here this is the not outlier companies, not outlier data, and these are outlier data. What this means, sometimes outliers comes from errors, which we can get rid of them, but sometimes it provides valuable information to us, which is the case here. Here the last price of the stock is the maximum value is about 3 units, and most of the companies will be categorized to this part, but this is the outlier. As we can see, the scale is far more different here. We have 3 here at the utmost scale, but here most of the companies are more than 10 units and even more. So based on these analysis, I decided to create 2 different tables. One for outliers and another for not outliers. So, and then analyze these 2 different data frames with each other. We don't want to just eliminate the high value stock market companies. That's what we should be focused more on indeed. But here, so we decided to keep them, to keep our valuable outliers and analyze our data here. So for outliers, this is, as I said, I created 2 new data set here: outliers data frame and not outlier data frame. Okay, so that's here, and I am trying to analyze our data based on the 5 distinct sector that we have: main, ACE, bound ETF, and for outliers we don't have variance part here, because we don't have any companies belong to variance part that is living in outliers. And for not outliers, we have 5 distinct data set here. I'm creating 5 dataset, and I'm creating a indexer function which create a time series data frame for us, which will be much more easier to analyze our data. I am setting date column as a index for our data frame. This is a function, and as you can see here, we can just simply say that I wanna grab this data from this one to this one, as simple as it's look like here. And I am feeding all of the not outlier main market, not outlier ace market, based on different sector to this indexer function, and create a time series from all of them. I am doing the same for outlier main market. I am trying to compare market by market, main market of outliers to main market of not outliers, or in loan market of outliers to not a loan market of not outliers. This way it would make more sense. Okay, and this is the head of our main market of outlier data. And yeah, I'm calling indexer function here to create, and to be able to do some comparative analysis, I should combine all of the data to each other. So I am creating this nice function, combine function, which can concatenate last price of df. Each data frame that is feeding to this function would be combined with gas, gold, or silver, and all data. And if there is some possible missing value here, it would be taken care of here. And yeah, here I am creating our combined function for outlier and as well for not outlier here. And here I'm building a heat map from all of the tables that I have created. Something very interesting actually. As you can see here, I am comparing main market outliers to main market not outliers. Okay, so in main market, so thing that seems very interesting here, in main market outliers, the if we can compare these two, stock price is positively correlated to gas price. Okay, but in not outlier, it has a negative relationship with gas price. And as it goes to a stock price and gold price in main market, which outliers, we have a negative relationship between the stock price and gold price and silver price. But here in not outliers, we have a positive and a strong relationship between these markets here. It seems interesting actually. And for ace market, this is, yeah, we have a strong, relatively stronger than this one, ace market here, relationship between stock price and oil price. Yeah, oil price here we have a negative relationship, but in not outlier we have a positive relationship. That's why let's explain how we can analyze our data based on sector by sector analysis. Yeah, for a loan market, as you can see, we have a positive relationship between and relatively strong relationship between the stock price and gold price, silver price, but here in loan market of not outlier, it isn't, it is opposite actually, and it isn't the same. Yeah, this is how it's look like. And at the end we decided to depict our data in some time series format. This is the format of the stock price, oil price during this time, this period of time. But you know, this is oil price, and why it's happening, it makes me curious. Why it's almost a straight line, but here we have. So that's why I get suspicious of normalization. So you know, if I come here, as I said, you know, we have 66 values mainly, but here we have 3, we have 9, we have 17. You know, it's that's what that's the problem actually. So to solve this problem, to tackle this one, I just create a function normalizer. I implemented the from pre-processing package robust scaler, and here I'm converting data. I'm normalizing our data for, and here it's the same figure for our data in time series. As you can see here, this is the stock price. Okay, stock price for not outliers during this about 1 year. 1 year it has been decaying with a little step. But here for outliers, main market, the stock price is increasing gradually, and the other are the price of, for example, gas price, gold price, which would be the same in our picture, which makes sense actually. Those aren't changing actually. And here for long market stock price, it's, and here, yeah, it has some oscillation here, but it looks like almost the changes looks like really similar to each other. Okay, that's the end of our presentation for assignment for milestone 4. And thank you, dear professor. I hope it would be useful and informative.